Here's something that genuinely surprised researchers when large language models first arrived. You can teach a model a brand new task without training it at all. You just show it a handful of examples inside the prompt, add a fresh input, and it figures out the pattern and continues it on its own. Nothing about the model changes, not a single weight. This ability is called in-context learning. It was named in the GPT-3 paper by Brown and colleagues in 2020, and it's part of why scale mattered so much. Today, we're unpacking exactly how it works, why it emerged, and why it matters for almost everything you do with these models. Now, to appreciate how strange this is compared against the way we normally teach a model something new. Traditionally, if you wanted a model to learn a task, you fine-tuned it. You gathered a labeled training set, ran gradient updates, and physically changed the weights. That works, but it's slow, it costs real compute, and you end up maintaining a whole separate copy of the model for every single task you care about. Contextual learning skips all of that entirely. You leave the weights completely frozen and just place a few examples in the prompt. There's no training run and no new checkpoint to store. The task is taught at the exact moment you ask, and the very next prompt can teach a totally different task with nothing carried over between them. So where does the learning actually happen if the weights never move? Let's follow one prompt through the model. You start by writing a few demonstration examples directly in the prompt. Each one pairs an input with the answer you want, so the model can see the shape of the task laid out in front of it. Then you append the new query, the actual thing you want answered, with no answer attached. It sits right after the examples, so the model reads them as the immediate context for what comes next. During a single forward pass, the model infers the pattern connecting those examples. Research suggests transformers can internally approximate a small learning algorithm over the demonstrations, right there in the activations. And out comes the answer, following the pattern it just picked up. The weights are exactly what they were a moment ago, byte for byte. The learning lived entirely in that one forward pass, conditioned purely on the context you handed it, which is why people describe it as learning that happens without any learning. All right, 3 ideas really capture what makes this behavior so important. First, the model learns straight from the examples in your prompt with 0 weight updates. No fine-tuning, no gradients, just conditioning on what it reads. Second, this emerged with scale. Small models barely do it, while large ones do it well, which turned out to be a big part of why making models bigger mattered so much in the first place. It's a capability you get almost for free once the model is large enough. Third, the examples mostly convey the format. Research suggests they teach the model the task's shape, its label space, and its style far more than they inject fresh facts. They're priming behavior the model already had, showing it which of its abilities you want right now. Okay, let's lock in the essentials. This ability lets a model perform a new task purely from examples in the prompt, named in the GPT-3 paper in 2020. Nothing about the weights changes. The learning happens inside a single forward pass, conditioned entirely on context. It emerged with scale, and the examples mainly teach the task's format and style rather than new information. This is the mechanism sitting underneath few-shot prompting, and a big reason prompting works at all. If you like AI concept explained this clearly, Standarity.com has plenty more waiting for you.